Hello interwebs, welcome to Let's Fix Computers. This is actually a Let's Build Computers. It's been a while since I've used that one before, but here we are. This is my PC. It's in bits at the moment. So this is my personal rig from home. It's a Torrent, a Fractal Torrent custom build. And I've got it in the shop today and taken it to bits because I've got some work that I've needed to do on it. I'm changing out my motherboard for a different one. I'm changing out the power supply, putting in some braided cables and stuff like that. So what we're going to do, I'm going to build this thing back up and I'm going to tell you about it while I build it. So let's get into it. So this PC's been running as a daily driver for a while now, and it's been very reliable for me as a gaming rig and what the computer I do most of my video editing on. But there's a few things that are being changed out about it. I originally built it up with this ASRock X470 Tai Chi in it, which is a very pretty motherboard. I'm a big fan of this motherboard. It's very pretty, although the problem is all of the stuff that makes it pretty is completely hidden behind the graphics card when it's fitted, which is unfortunate. However, I run a Ryzen 5800X, and the 5800X I own a couple of them. I've got another one in the shop on an X570 board, and that one seems to boost just a little bit harder, and I think it's because it's in a newer motherboard, basically. The X570 boards have got better VRMs on them, newer BIOSes, etc., etc. So I'm swapping out my X470 Tai Chi for an Asus X570F Strix. So this is a really nice X570 board. I also own another one of these that is also in the other shop PC. And I really like this motherboard as well. So I got hold of a second-hand one of these that I'm going to put in here just so I can eke that little bit more out of my 5800X. So I've already pre-fitted the CPU, my SSDs, memory, and so on into here. So that's ready to go in. The other thing I'm changing out as well is my power supply setup. So the power system in this has been coming off of this RM850X that I put in when I last rebuilt this thing. This was also a second-hand unit, and unfortunately it's got mad coil whine. And that coil whine, it works just fine, but that coil whine, this is a very quiet computer, and when it goes on load and I hear that coil whine light up, I'm like, oh, I've got to get rid of it. So I have now obtained a nice refurbished Corsair RM1000X. So this should hopefully have no such issues. I don't need the extra wattage. However, because of reasons, I got this at a very agreeable price. So, 1000-watt power supply. It's the last unit that'll ever need to go in this PC. I'm quite a big fan of the RMX series as well. They're nice, quiet power supplies. They're nice, high-quality units. It's a shame about that 850X having coil whine. I don't know what the deal with that is, but it is what it is. So, in addition to that, I've also got a Corsair braided cable set. I also bought this as a open box set, so I got this on the cheap as well. So I've got a full set of braided cables here. They're all a bit messy at the moment, but once I put some cable combs in there just to line up all of the wires and everything, those will look really nice. Previously, I've been using braided extensions in this PC. However, because of the braided extensions, around the back there was just loops and loops of cable all bundled up to bury all of the excess. Whereas now I've got braided cables that go from the power supply back, no more extensions, just braided the whole way. So yeah, as I say, like cable mod kits are mega expensive, but the Corsair braided starter kits, the braided starter kit includes the ATX, the CPU power cable, and 2 PCI Express 8-pin cables, and is like £40. So that's probably about $40 or something like that, which I think is actually rather good value for money for what you're getting. And because they're Corsair, they're going to be good. Because the third-party ones, I've never had a problem with them, but I've heard that there are bad ones out there. So make of that what you will. Finally, this adapter here, this is a dual 8-pin to 12-pin connector for my 3080 Ti here. This is a no-brand one that I think I picked up on eBay for like £10. No idea how good a quality it is, but I've had no problems with it at all. So that's the guy that's going to power my graphics card. So, the Fractal Torrent, when this case first came out a while back, I immediately fell in love with the design of this thing because I'm a big fan of anyone who designs a case that actually has an interesting front panel on it, because we're still in the midst of the modern airflow meta, and by the airflow meta I mean we used to have cases that had front fans. Then we had the solid front panel meta, where just every computer case just had a solid metal front on it. And then we had the tempered glass meta, where suddenly everything had tempered glass on the front of it. And then a few people made the observation of, if you put tempered glass in front of fans, they don't blow anything. And then the airflow meta started, where everything was just a mesh front grille. And mesh front grille cases are great. They provide brilliant cooling to the computer, and better cooling means less noise. However, every case now just has a standard mesh front panel on it, and it becomes very difficult to find any cases that are meaningfully unique in any way. And this is one of the reasons why I'm actually quite a big fan of some of the oddball cases that Corsair have made, like the Corsair 220T and the 275R Airflow, because they have fairly radical designs on their front grills, which are fairly divisive in the community. A lot of people hate them, whereas people like me, I like it because I appreciate the fact that Corsair were trying to do something different. And then, the Fractal Torrent came along with these massive louvers on the front of their case. And when all the fans are fitted on this thing, you have the option of either having these massive dual 180mm fans up front in the stock configuration, and you'll see those through that front thing, or with the configuration that I'm running, you can have triple 140mm fans up front. So the standard configuration puts the 180s at the bottom, puts the 180s at the front and the 140s at the bottom. However, you can reverse it if you're running an AIO liquid cooler like I am. I've got a 280mm NZXT water cooler here. And so I've got the 140s up front so I can front mount my RAD, and then I have the 180s at the bottom blowing up onto the graphics card. And what this gives you is an absolutely bonkers amount of positive air pressure. And I run no exhaust fans in this case. So you'll notice, like I've got all the fans out at the moment, but I run no fan at the back, completely wide open honeycomb mesh at the back. And when this computer is running under load, if you put your hand behind the case, you'll just feel a draft of hot air coming out the back. And it's literally just a wind tunnel of all of those intakes just blowing everything through the case. That is what the Torrent is all about. It's a torrent of airflow. You're supposed to have a torrent of water, but thermal dynamics or whatever. Anyway, so when I saw this case, I was like, that's cool. I like that. And the fact that it had such massive airflow was very attractive to me because I had a NZXT H500i, which is notoriously bad for airflow. And it works. A lot of people are just like, NZXT. Like, yeah, the airflow is bad, but it works. That's the important thing. But your fans have to do more work. So I bought one of these. And the front grille at the front there comes off. And now I'll mount up the front radiator again. So I bought one of these, and my first impressions of it, the long and the short is, if I'd known that it was this big, I wouldn't have bought it. This is a big case, and it's very good, but it is very big, and you need to keep that in mind. But that much being said, with the way that my desk is set up these days, I have lots of space, so I can now accommodate this thing, and it looks great. I'll show you some pictures of what it all looks like when we're done. So it's not so much of an issue, but the thing you have to keep in mind if you've got your eyes on a Torrent is it's a big boy. Now, there are smaller versions of it available. They have since released a Torrent Compact and a Torrent ITX. And the Torrent Compact, I think, is a very interesting case. I think that probably offers most of the advantages of this in a slightly smaller form factor that's a bit more sensible. However, the ITX, I'm less convinced about that. I don't see the purpose of the Torrent ITX because I don't. It's okay, but I think you're paying the ITX tax just to save another couple of inches. With ITX, I think you need to go really small or not bother. For everything else, build in a mid-tower. I think mid-towers are where it's at, personally. I'm a big fan of them. So that's that. However, this is the big one. This is the big Torrent. So this was also the case that had a problematic fan hub on it, but I don't use the fan hub at all. I do have the replacement one, but I just don't use it. It's not fitted to this. And I do all of my fan control and RGB control using a standalone controller. And we'll talk about a bit more about that when we get to it. However, I do it all standalone, which gives me a much higher degree of control over things. So I'm going to mount this up on the front here. Because I've already got all my fans pre-fitted, this guy just slots in now. And I'm just pulling these cables through. Who's holding me up? Ugh. There we go, that goes on there. And now we need to stick 4 screws in there to hold that all in place. There we go, that's that fitted. All right, I'll just put in the lower dust filter again now. So that guy slides in there. And the front filter, that guy just unclips like that for cleaning. And I'll put that back in. I've pre-cleaned all of this. That was another reason why I had this in for complete disassembly. Because I've had this case for a while now, dust builds up over time. Even with all of these filters, eventually everything will get dusty. And so, you know, once a year or so, I like to do a complete strip and rebuild on my computer just so I can actually detail it all. And I still need to do this actually. I still need to just get a cloth and just go over each one of these with the cloth just between 2 fingers and just wipe off all of the dust. Because even an air compressor won't shift this kind of just surface dust. And that's what just makes things look old. And if you just take the time to go over all of it like this, it really shines up. And it doesn't take long once you get on with it. And so as you can see, and you'll see more when it's all on, depending on what angle you see the case at, depends on how much of the fans you see. It's a very neat effect that is only possible because of how deep this front grille is. It's a big, heavy piece of material. So now I'm just going to mount up my, my AIO water cooler again, just so that's in place. And then I'll have, apart from the graphics card, all of my big components in position, and I can start plugging in cables. These 2 big fans that go down the bottom, I'll be putting in those a little bit late when I've wired up the motherboard, because those have got quite a tight fitment on them, which I'll show you a bit more in a minute. So that's going to go there, and we're going to need some thermal paste on that. The 5800X that I have in here is a very oddball CPU. I'm a big fan of it because it routinely appears at very weird prices for its position in the product stack. Like even right now, as of the day of recording this, you can buy a 5800X for £220 sterling. and that's an 8-core 16-thread CPU that will all-core boost up to 4.7, 4.8 gigahertz quite happily for, you know, 220 pounds. That's a lot of horsepower. The only catch is that it's an animal to cool, because the 5800X has all 8 of its cores on a single CCX. That's the small compute dies on AMD CPUs. The 5800X is binned in such a way that all of the cores are in one place on the chip. And that means you've got a very big hotspot on the chip that's very difficult to effectively cool. So you often have to put an overkill amount of cooling on them, not because they use that many watts. The actual TDP of the chip is not horrifying, but just because it's very difficult to get heat out of the chip. So I have this NZXT Z63 AIO, and it's the one with a little LCD on the front, so it shows temperatures and things like that, which I very much enjoy because it means at a glance you can just see what the computer is doing, and it really adds some life to the computer, just so there's, you know, stuff to look at when you look into it. There we go. Now I've got a couple of wires down here for like the HD audio that have got the old ketchup and mustard colors as they call it. I like to call it Fisher Price because it's even more colorful than ketchup and mustard. And having that splash of color in here is really annoying when you're trying to build a show PC. So top tip, I've got a roll of this stuff. It's fabric tape, and it's often known as stick tape because it's used on hockey sticks. You wrap your hockey stick in it for grip. And this fabric tape, you can use it like you would electrical tape, but it's very soft and floppy, and it leaves a really nice matte finish on everything. So I'm just going to wrap any colored wires like this in stick tape just to get rid of the color and make it look like it's braided. It's a really quick way of just hiding something. I've done the same thing already with the front panel cables here. So the noodly boys here for the power switch, power LED and stuff like that, I've already stick taped these up to the ends of them. So I've got a nice single cable there instead of having a group. So right now I'm just plugging in all the cables that are going to places, and I'm just threading them through and plugging them in just so I can put them in order, because I know once we get round to the back and when I start putting fans into place, we're going to start closing off access. And that's where one of the weird things about this case come into play. In a big case like this, theoretically it should be very easy to build in because you've got so much room. However, that is the oddity of the Torrent, is despite how big this case is, access around the motherboard actually isn't very good. It's not the worst I've seen, but you do have to plan some things ahead. And the top isn't too bad for this, but certainly the bottom is terrible because of when you put these fans in. But that also comes down to the fact that I'm running the 180mm fans at the bottom. If you're running the 140s at the bottom, as per the stock configuration, this is much less of an issue. But that's why this case can be more complicated than it looks, because all of the space and the size of this is actually in the open air inside, not in the utility of it. So the irony is you've got lots of open space in here, but you can't use any of it because it's there to look at. This is one of those cases that I would refer to as a cabinet case, where it's big not because of utility, but simply because of the idea is it showcases the components inside. Now comes the fun part of putting cable combs in. So for combs, there are a couple of different types. I like these ones that are like an open comb, as I would call it. It's very common to see big, square, blocky looking ones, and I don't think those are very attractive. I prefer either open combs like that, or if they are closed off, I like them to have rounded corners like these ones do. When there are big, square, blocky ones, I think they're quite ugly, personally. So these open ones, you can slot these between the two rows of pins, and then you've just got to line your pins up. There we go. I've just put my fingers between the two rows of cables, and now I'll just slide that guy in between and then just click the wires into the channels. And now, if you're lucky, you should be able to slide it up and down the cable, although this one is actually very tight and won't allow me to do that. That's going to make this very tricky to train, because next what you have to do is what's called training the cable. And that means, and what training the cable is you need to tug and pull and fettle all the wires so it moves in a nice smooth curve. Like, for example, this cable has been trained. You can see it's following that very fixed curve. And what that is when this is in position on the card, it does that very smooth sweep up into the card. And these wires are all trained to follow that curve, so you get a nice fixed curve. Whereas this cable now, when I just plug that in, it's just going to go bleh, and they're just going to splay out in all directions. So this is easier when the cable can move up, the comb can move up and down the cable, which this one is going to be a pain in the ass and not do. So I'm just going to plug it in and just start manhandling it. The wiring harness for the water cooler is also quite complicated. It starts out with this multi-pin, I don't know what that is, 10-pin. Yeah, I think it's a 10-pin connector, and it's got a RPM, a pump RPM header tail coming off of it that goes into the CPU fan header. Then we've also got SATA power, a triple fan connector, and an RGB connector. So the RGB connector I don't have connected up on mine because we don't control any RGB from this. That's being done standalone elsewhere. But this whole thing needs to plug into the top of the pump, and it's quite a noodly affair. So I'm also going to wrap this in stick tape to turn what are a bunch of separate shiny wires into a nice solid loom instead. So once again, I'm just going to get my stick tape and just wrap this guy up. Now these 180mm fans have 1 meter long cables on them, which is ridiculous. I would really love to just cut and re-terminate these cables to a more reasonable length, because you just literally have to just wrap these up and bundle them in the back of the computer. It's very annoying. However, I'm not willing to cut and re-terminate these, so I'm just going to thread them through. I think I can put them through these holes. We'll find out. And now we hope that these fans will slide in under all of the wires going to the motherboard. Now the trick to getting this assembly in when you've got these wires down here is there is a gap between the fans, and you need to put all of your cables coming through from the back of the motherboard between the fans. And that's the key to making this guy go in. It's very annoying that it's this much trouble. There we go. Right, and now at this point I can actually put my graphics card in now. So this is a RTX 3080 Ti Founders Edition. which I managed to get. I got lucky, managed to get this at retail price during the GPU shortage, just from being in the right place at the right time, in short. And it's a lovely graphics card. It's not the quietest in the world, if I'm brutally honest. At full chat, this thing is quite loud. And that's why I actually run this thing undervolted. I've been doing a lot of tinkering with this thing lately, where I downvolt it by way of lowering the power target and then undervolting to bring the clock speed back up under those low power conditions. And once I've started this thing up, I'll give you a very quick view at what that looks like. It's a bit of a dirty setup, but it does bring down the power consumption and the noise level of a Founders Edition card quite a lot. Wouldn't be necessary on a partner card. However, although the partner cards are quieter and can reach higher speeds, I do love how pretty the Founders Edition is. This is the only flagship graphics card I've ever owned in my life, so I'm quite proud of having one of these. I've always ever owned second-hand cards, or you know, not quite top of the line. I mean, obviously the 3090 and now the 40 series exists, but I think it's safe to say that this is a very respectable graphics card. So I enjoy owning one. It's one of the few times I've actually got the tops, you know, a very high spec graphics card. So there's my power cable that goes in, and as you can see, this cable is pre-trained, so it gives just a nice smooth sweep down to the bottom there. Now we find ourselves around the back. So I'm going to start out just by putting in the last couple of power cables that we don't have plugged in at the moment. So my ATX 24 pin, and I'm going to plug in my PCI Express 8 pins as well. And then we'll have all the cables falling out the back, and I can start pinning everything in place. And at the same time, I can start telling you about the logic behind how my fan control and RGB control setup works. So I'll start out by getting this guy plugged into the motherboard, and I'm just going to run that through this hole here. Plug that guy in. That cable will need to be sorted out. And now I can bury all of that excess up the top in the power supply enclosure here. There are zip ties up there to tie things down. So we've got a bit of a bundle here. I'm not going to fret about this too much because we're going to have to open and close cable ties many times during the course of tidying this thing. So let's keep an open mind. So for tidying, I'm going to start by connecting all of the big stuff up and trying to pull as much of the cable back to any place where I can bury cable as soon as I can. So I've got these plugged in, and now I'm going to pull all of this up. Pull it all up and just roughly put that into place. And we don't want to pull it tight. We just want to give a little bit of give on it here, just so we can move things around and move things into place. If you make things so they're properly wedged in, you might find you can't get panels on because looms have become too thick and stuff like that. And now what I'll do, I'll just unplug those from the power supply again and just let them turn around into whatever direction they want to face in, just to relieve any twists and tension that are on them. And all of this just helps when you come to actually zip tie things down. Again, this is all about training the cables to flow in the direction that you want them to and they want to. If you're wondering why I've got these extra stray ones, the dual 8-pin to 12-pin actually doesn't have the extra 2 pins populated, so I don't actually have to have these guys connected. They're not actually necessary for this adapter. I don't know the reasoning behind that. I think the 12-pin just doesn't use any sensing at all. I think it's literally just 12 volts and 0 volts, that's it. Now, let's talk fan control and RGB. So there's two ways you can do all of your fans and or RGB. You can have a standalone controller, or you can control them from the motherboard, or your case might have a degree of RGB control. This case has none of those things, despite the fact that this case comes with 5 fans and 6 RGB devices. Each fan is an RGB fan, and there's an accent strip up the top. So you've got 6 RGB headers to deal with on this thing. It has no built-in RGB control at all. And having 6 RGB devices to deal with is actually quite a lot. The fans, you can obviously hook up to the fan hub that it comes with, and that gives you up to 9 fans into one. And I think the logic for that is up to 6 fans for a push-pull at the front, 2 at the bottom, that's 8, and then 1 at the back, that's 9. So that's why you would have a 9-fan fan hub in here, is that effectively Fractal have looked at it and thought the most fans you could possibly imagine putting in this thing is going to be 9. However, as I say, I'm running 5 fans and I am not running the fan hub. So this is an NZXT, I forget what they actually call this. It has a really dumb name. It's like just Fan Hub 2 or something like that. But it is a 3-channel fan controller and 2-channel RGB controller. So I have the fans divided up into 2 sections. I've got the lower fans and the front fans. And I use 2 of the fan channels for that, leaving 1 of them empty. And that means that I can have the front fans going to 1 channel, which is watching the CPU temperature. So as the CPU comes on load and heats up, the front fans blowing through the CPU radiator, those speed up in order to provide more cooling to the CPU. And the other one has the lower fans connected, which means, and that is watching the GPU temperature, which means as the GPU heats up, the lower fans spin up. So this is really useful because on a normal computer, when you're just running just the front intake alone, you often don't have independent control of CPU and GPU cooling. And that means that under a gaming load, for example, realistically speaking, you're probably having your front fans blowing through your CPU radiator. And that means that under a gaming load where your graphics card is under heavy load, but your CPU isn't really under very much load, you're not increasing airflow to the GPU. So the only other way around that on a traditional case would be to top mount your radiator. So your exhaust fans are CPU controlled, and then your front fans could be GPU controlled, for example. But and that would be a solution to that. But the other issue that you will have as well is that unless you're using a USB controller, it's very difficult to control fans based on GPU temperature. You can't do that through motherboard control at all, for example. And that's why I'm using this guy here, because this guy connects to USB and it plumbs into NZXT CAM, which gives me full control over all of the fans based on any temperature in the computer. So that's the fan theory. Likewise, because it has a 2-channel RGB controller, I can hook up all of the RGB to that. And I have the RGB divided into 2 zones, I think. I've got the triple fans on 1 channel and then 2 fans plus the accent strip on the other channel. Now, in order to connect ARGB headers, so that's this guy here that's got, it's a 4-pin wide header with a missing pin. That's the digital ARGB header. The NZXT one only wants to accept NZXT RGB stuff. Now, in order to connect third-party stuff up, I made up these little adapters here. And what this is it's an old fan cable that I've chopped off and soldered onto an RGB coupler. So I now have an ARGB header into a 4-pin connector for the NZXT hub. And what this does is it tricks the NZXT controller into thinking that a standard NZXT LED strip is connected. And that's how I'm using an NZXT controller to do third-party ARGB. Let's start putting this in. The first thing I've got to do, I've got these ridiculous 1-meter long cables coming from the bottom fans. These just need to be coiled up and zip tied out of the way. So let's roll the music and start the cable tidying. There we go, everyone. That'll do it. It's not a work of art. However, this many wires is tough to tidy. I'll actually be amazed if everything works first time, especially because RGB cables like this connector is crap. It's not locking. It doesn't get a good connection. So I'm 99% certain that some of the RGB is not going to work first time, and I'll need to plug and unplug a few things and that kind of thing. These fan connectors are also a little bit loose on this one. I don't know why. Maybe just well worn. So those might need doing at some point as well. I'm very tempted to just get the hot glue gun out and just put some spots of hot glue on these just to hold them in place. If you ever wonder why system integrator PCs, pre-built PCs have stuff hot glued in, it's because connectors are crap. And you know, like if you ship that across the country, these are going to come out in shipping. I guarantee it. So yeah, in case anyone is wondering, that MX500 up there, that's just an archive drive. I would love for that to be another M.2 drive. However, 2.5 inch 2 terabyte drives are cheap, like the Budgie. So yep, I've got a little SATA drive up there just doing its thing. So yeah, that is ready to go together. So I'm going to put the top on, and we'll put the covers on, and we'll see if it works first time. Yep, RGB headers were the wrong way around. Okay, right, I can see I've got a DRAM light on, so it's not posting. So what I'm going to do, I'm running out of time on my filming session today. So I'm going to cut now, sort out that post issue. Probably just the RAM needs reseating or something like that. And then we'll cut to the point where I've got this installed, and we can start talking about how the RGB is set up, the fan setup, and so on and so forth. So, see you after the cut. Okay, so now I've got the computer back up on the desk and it's looking very pretty again. I will give you guys a quick rundown of how I have it set up to give the RGB effects and the cooling setup that I have. So let's take a look over at NZXT CAM, which is what I'm using for all of the lighting and cooling configuration. So NZXT CAM is actually quite a comprehensive bit of software. I think it's very underrated. However, it's spoiled by the fact that the NZXT ecosystem isn't very good, in my opinion. This is speaking as someone who has had an all NZXT PC setup previous to this one, which is why I still have the controllers for it. But CAM as a piece of software is actually not too bad. I think it takes a lot of flack that it doesn't deserve, but it does a few things very well indeed. So let's take a look through it. Let's check out the lighting first. So if I go down to the lighting tab, as you can see, we've got two RGB channels and my Kraken AIO pump As I mentioned during the build process, each channel has got, well, channel 1 has got the two 180mm fans on it, plus the accent LED strip that's along the power supply enclosure. Then channel 2 has the 3 front fans plus the add-in RGB strip that I've got fitted to the top of the case. I didn't point this out during the build, but the RGB strip that's in there, that's one that I've added in for wash lighting. And it's quite important for a case of this size to have an LED strip, because unless you have, like, seriously a lot of fans, the case is just too big to effectively fill with light, and you'll just have shadows everywhere and it won't look very good. Personally, in my opinion, I think Fractal should have ditched the accent LED strip on the power supply enclosure and actually had a built-in RGB LED strip for the entire case, but it doesn't matter. Anyway, so those are our 2 strips. As you can see, all of them appear as just 2 channels. If you had multiple things in here, multiple fans, multiple strips that were actually NZXT, then CAM would see them as independent devices. However, CAM is being fooled into thinking that I just have 2 really long LED strips installed. So I have these set to the Starry Night effect, and CAM's Starry Night effect is actually incredibly effective. All I've done is apply this shade of purple to them, which I think is actually the default NZXT purple. It's a very iridescent purple. It's almost UV in the way it looks on LEDs, and it gives that very ghostly shimmer effect that you can see in the video here. And the Starry Night effect interposes that with complementary shades. So it throws in some reds, some turquoises, some whites, and it just very gently shimmers and pulses the LEDs between those. And it adds in a very nice effect that has all of the fans having some degree of motion and life to them, and like the RGB strip as well, just very gently and slowly twinkles without being distracting or flashy at all. Out the corner of your eye, you'll never see it, but if you actually stop and look at it, you can see it softly shimmering and just being alive, kind of thing. And that is my favorite kind of RGB effect, something that looks animated and alive without being flashy and distracting. So yeah, the Starry Night effect, it's very good. It does all of the secondary colors for you, which make it very simple. So below that, we've got the Kraken LCD display. Now the Kraken was the first AIO pump to have the LCD on the pump. But unfortunately, it's quite an early example of it, and there's not a huge amount of customization you can do here. You can select it to do different things. You can have it just show an image, or you can have it showing just a temperature or a load or a clock speed, or you can have it just do some other visual effects. But you can't really customize any of these in any meaningful way. For example, what would be nice is if I could say a quad infographic and say I want CPU temperature, CPU clock speed, and GPU temperature, GPU clock speed. That would be very handy. Can't do that. Likewise, on the dual infographic, it will show me CPU and GPU temperatures, but I cannot swap those temperatures out for a different one. So I couldn't have, say, CPU temperature and liquid temperature. No, it's just, that's what you get. However, you can change the colors. You can set the accent colors and the main text colors, which is quite nice. So I have those set to, as you can see, purples, blues, and whites. They look like very strong colors in the software, but they're a lot more washed out in real life, just simply because small LEDs and LCDs on devices like these are not very color accurate. So when you're doing an RGB setup like this, don't approach it saying, I'm going to do this exact color. You need to kind of just fiddle about with the colors while you're looking at it, and say, okay, that looks right. Even though in the software it might look really whack. Do it by eye, by looking at the LED and seeing how it looks in real life. So that's the RGB setup. So onto cooling now. If we go to the cooling tab, we've got the RGB and fan controller with 3 fan headers on it. The first channel is not in use, that's disconnected, and channel 2 and 3 have got the other fans connected to them. Channel 2 and 3 have the two 180mm fans on them, and these I've got custom fan curves that are tied to the GPU temperature. So it runs a fixed speed of 20% until the GPU hits 60 degrees. So once the GPU has hit 60 degrees, it's safe to assume that there's some kind of load there. And so these fans will start slowly ramping up, and they'll hit 50 degrees up to 70°. And then they'll push a little bit further, and that is generally the target of where I'm aiming for, around there. So they'll ramp up to blow cold air onto the GPU while it's actually under load. Then if the GPU is actually in runaway and we're hitting 80 plus, then as you can see, the fan curve then starts ramping up big time up to 90 degrees, where it's assumed that something has gone wrong and I want all the fans on maximum speed to try and deal with that. However, theoretically, we should never reach this point of the curve. So fan connected 3 is running exactly the same curve. And likewise in CAM, I can select I can select either CPU or GPU, and this is the party piece of doing this with an NZXT controller and CAM. Again, you could achieve the same thing with something like Corsair iCUE, but you can't do this with motherboard attached fans because the motherboard can't monitor the GPU temperature. So it means that your fans have to be tied to either case temperature or CPU temperature. So then finally, on my AIO, the pump, I've got a very simple curve dialed into this. I've basically got an idle speed and a load speed. Idle, it drops down to 60% on the pump speed. And then if we go past 50 degrees, I assume that there is a load on the CPU, and it jumps up to 90%. I don't have it hit 100% because this particular AIO, the pump is kind of whiny at 100%, so I have it just at 90, so it's not quite flat out. In my opinion, there's not a lot of value in running an actual curve on a pump. A lot of AIO pumps can have a very annoying whine to them, and if you put a curve into their control, it often means that your ears will just pick out the pump noise as it goes up and down, especially because on a modern CPU temperature jumps around a lot. So you'll hear very distinctive noises from the pump, and it's very annoying to me. So as you can see, I run just a flat idle and load level on that. Then finally, the actual radiator fans. So these are the 3 front fans on the case. 2 of them blow through the radiator. The other one just blows into the case. But I have them all on the same profile just because there's no point in doing it any other way, in my opinion. And as you can see, I've got a very, very aggressively silent fan curve dialed in here. We stay at 20% all the way up to 65 degrees. And then we start ramping up. And even then, we only aim to hit 50%, and then we start doing a final ramp up if the CPU is really going to town. And this is perfectly adequate because most of the work in cooling a CPU with an AIO is in circulating the water. If you circulate the water and you have some airflow through a big radiator, it doesn't take a lot to keep the CPU cool. So this looks like a very aggressive curve, but actually that is perfectly adequate. And I've done tests on this and found that if I bring this curve up at all to make it more, I suppose making it higher would be more aggressive, but if I make it faster, so more fan speed, I find it makes almost zero difference to the actual load temperatures. So again, this is also assuming a high airflow environment. If you have a lower airflow case, you're not going to be able to run fan curves like this. You will need to run your fans harder to push and force air through a bad airflow environment. So another thing that I want to point out that some people may have noticed is I don't run stop-start fans. I can have these fans just switch off at idle. But I actually run, with the exception of my graphics card, and the fan on that will spool down when it's at low temperature. I actually run my fans at a minimum of 20% all the time because they are fundamentally silent at 20%. They are slightly audible, but come on, who's counting here? You know, you're not going to pay attention to fans at 20%. And what this does is it staves off heat soak. So if you have these go to actual full stop, what you'll see is your liquid temperature will always be creeping up because there's nothing cooling the liquid. And that means that when you do suddenly hit the CPU with a load, your liquid temperature is going to be up in 40 degrees or the mid 40s and is not going to be able to cool the CPU properly because the liquid is too hot. And that means that your CPU immediately bangs up to a very high temperature and the fans ramp up to a very high speed, and they have to get rid of all of that heat soak before they start cooling the CPU properly, and then they'll start coming back down again. Whereas if you constantly run a very low fan speed all the time, we're constantly keeping that liquid temperature down low in the high 20s. And that means that if the CPU bangs on load, the liquid is already cool and is just instantly cooling the CPU off. So I have done tests and I've found that this is a far more effective method. Stop-start fans look awesome. It looks really cool when your computer goes idle and all the fans switch off. But in actual practice, you will get quieter overall performance by running a constant 20% than having stop-start fans that have to overcompensate when they switch on. So over in MSI Afterburner here, I've got my graphics card settings dialed in. Now, firstly, it's worth noting that because I have a Founders Edition graphics card, I've got fairly good silicon on this graphics card, so I can get away with a lot. You might not get away with voltage curves as aggressive as mine here, but you know, this is just I'm making this video just to give people ideas on things that you could try out. So what I've got is a very heavy undervolt, and the objective of this setup is to reduce heat, thus reducing noise, and also reduce power consumption, because electric is expensive and I don't like bills. So and running a 350 watt graphics card is not fun. So this setup actually knocks about 60 or 70 watts off of the total power consumption. So what we do is I run an 80% power limit on the card, which massively starves it of power. And then I run this very flat voltage curve, and the objective of the curve is to achieve 1800 megahertz as soon as possible and then just stay there. So this lowers the theoretical maximum boost clocks of the card. But in real life, this graphics card, because of limitations on cooling, it doesn't reach super high clocks anyway. Even if I took off all the power limits and let it run as hard as it can, the temperature will catch up with it and I'll get reduced boost clocks because we're running hot. Or failing that, the fans have to be obnoxiously loud. But I don't need to run this card ragged, so I've got a very conservative target of 1800 megahertz, but it hits that 1800 megahertz really low down on the curve, like seriously low. As you can see, we're way above the stock curve here. And so what that means is that even though it's only got 80% of its power budget, it's shooting for 1800 megahertz at really low voltages. And this means that I actually only lose 1 or 2% performance in benchmarks. I've run tests with this setup on superposition 1080p extreme. At stock power levels, this computer will score about 12,000 points in 1080p extreme superposition. With this setup dialed in, it gets about 11,800, 11,900. So I've lost a tiny bit of power, but I'm using nearly 70 watts less actual power from the wall. And that's quite a good trade-off in my opinion. The only other thing I've got dialed in here as well, I have tweaked my fan curve slightly. I'll just show you what that looks like as well. What I've done with the fan curve is basically I've brought down the minimum level and have the fan cut in sooner. So the stock power level on this one, it actually sits up at 30% minimum and cuts in at 60. But what this means is that when heat soak sets in on this graphics card, it will slowly creep up into the 50s, and then the fan cuts in at 30%, and I hear the fan running while it brings the temperature back down. And it'll do that just on desktop loads, not even in game. So this custom fan curve has the fan cut in much earlier at 50%, but at a much lower speed. So that means it's keeping that heat soak away, and the fan is on more often, but at a lower speed. So again, you don't hear that fan cutting in and out. So same deal as the stop-start fan procedure. So I hope you guys found that kind of interesting. That's my home PC setup. I hope you like it. I certainly do. I'm really happy with how this PC runs, and I'm really happy with the desk setup that I have. This has probably been my most favorite computer setup of all time. And I'm very proud of how I've got it running now. It's very comfy. So if you saw anything you like, then feel free to take ideas, try implementing them in your own way, and leave a comment down below on stuff you think is cool or stuff that you're doing for a similar thing, to give other people ideas. Past that, see you all next time. Bye for now.